Hi, this is Devon Munsell, and I'm creating this video to explore the database that I created for Geography 582 at Southern California. It's summer semester 2011, August 5th. I'm going to begin with a slight overview. The beginning of this presentation is an introduction where I'm going to cover the background of urban planning and this project in general. Next, I'm going to move on to the scope of the project and the purpose, basically what I'm trying to accomplish by this project. After that, it's time to explore the database contents. Usually the best way to start off with those are the featured data sets, kind of the backbone to the geodatabase. Then the topology rules that move on to them, I'm going to provide a summary of them. And the relationship classes after that to sort of explore the connections between these data sets and the feature classes within them. And then finally going to take a look at a few domains. The project will end with this small summary of my findings. Urban and regional planning is a major industry within GIS. In recent years, it has become more and more important to have a strong GIS with a database behind it that's effective and is able to work well with the professional planners. To date, ESRI has not created a database model specifically for urban planning. I was able to find one for local government, but there wasn't really anything specifically for urban planning, although the local government database model was extremely helpful in creating this database. Effective database and professional planners, for professional planners must be able to handle multiple features and relationships between them. This is essentially because of the multidisciplinary nature for the field. You have to deal with civil engineers, landscape architecture, professionals, along with politicians. And because of this, you have to deal with quite an extensive amount of data, and you basically need a database that will be able to handle this. So the scope for this project is basically a starting point for any planning organization. Now this is just the general everyday planning organization. There are a lot of subtypes for planners, such as environmental, traffic planning, economic development, and the like, just to name a few. However, this is just for planning tasks. Examples would include working with zoning ordinances, parcels, the transportation effects for that parcels, looking at protected lands and things like that. Now, it wouldn't be practical to account for all planning functions because, as hinted earlier, these are very numerous. Basically, my goal here was to create a starting point for these and just sort of be able to get a little bit of everything. The purpose for this was basically to accommodate for this variety of the world that the planners interact in, while creating logical relationships in between them. I found it really vital to follow a lot of the fundamental core concepts that we have viewed within this course. Okay, I'm going to begin with featured data sets. These are the data sets in which feature classes are contained within. As you can see, I have 7 here, listed in alphabetical order. The first one is addresses and names. The addresses and names data set contains basically information about the addresses along the streets and the names for those streets. This one contains information about the footprint for buildings, and that is important because certain zoning ordinances will require a building to be so far back from the street, depending on where it is in the community and how busy the street is. Next, we have census geography. Given the wealth of data that can be found within the census, it doesn't make sense to really create any data set, geodatabase without having some sort of link to this information. So this is going to contain data on census tracts, blocks, and block groups, making it easy to import information into this from the census into a planner's database. Can compare it to local information. Next, I have municipalities, another form of district. This is going to include city and town boundaries as well as county boundaries. And next we have parcels, which make up the municipalities. Each individual parcel is a plot of land that is controlled by zoning ordinances, has its own tax identification code. This also includes subdivisions, which are parcels that are broken up into many parts and sold individually. Next we have planning. Now, although all of these could technically be argued as planning data sets, this is the one that's really makes this database what it is. The planning feature data set contains information on zoning codes, land use codes, and the like that really deal with the everyday functions of the planning department and sort of their specialty, featured classes and things. Lastly, we have the transportation, which ties a little bit into all of these other classes. The transportation data set is going to contain information on not only roads, but bike paths, sidewalks, trails, and even bus information. So this is going to really tie all these other information with a nice solid line network. Okay, now I'm going to explain each data set individually. This is a screenshot taken from ArcDiagrammer. I decided to show these two data sets together because they're connected by this relationship class here, building to address. First, the building footprint, as I said earlier, is part of the building's feature data set, and in fact the only feature class within that data set. It just sort of stands alone by itself because it's a little bit different than all the other boundaries. Now this is more useful if we tie it with the address, which in turn is linked with street names. You can't see it over here, but through this annotation class and relationship class, this is tied with the road segment class over in the transportation feature data set. So this connection here really links the buildings with the transportation system. Now moving on a little bit slower, the address, as I said, is the address along the individual street names. Also in this data set, the street name annotation, and annotation is basically a label that is movable within the GIS, and for printing out maps or a simple GIS user will be able to see the local street names and sort of be able to get a better feel for where they are in the map than without them. Next, I'm going to explore census geography. This is broken down to census block, block group, tract, and topology. And lastly, we have census topology. This contains the topology information for each one of these groups. Now, just to touch on census geography a little bit, census blocks, if you bring a bunch of those together, they will create a census block group, which is composed of many blocks. And similarly, a census tract is composed of many block groups. Now, in order to keep this sort of hierarchy consistent, I created the census topology. Now this will ensure that the blocks will stay within their block group and the groups will stay within their tracks. This prevents, in case they get moved or otherwise recalculated, that the blocks will switch with the groups and the groups will switch with the tracks, because otherwise if you move one it'll kind of turn into a little bit of a mess. Next we have municipalities. There's two different boundaries that I defined here, city boundaries and county boundaries. Here I have a little example of what my county boundary look like. You have the standard object ID, which is unique for every individual boundary. The county name, and the size of the county. And then these ones over here, shape and shape length, are standard GIS automatic feature sets. Obviously, working in any sort of public planning, keeping in mind of the different boundaries is important. You obviously have to stay within your own boundary, and when you cross boundaries, different zoning ordinances, master plans, and local plans switch, as you cross those boundaries. Next, we have parcels. Parcels are sort of the building blocks of urban planning. Each parcel is connected with the zoning class, some sort of land use. It's kind of what connects the citizens with the planning department. So you can see here the parcel is the main feature class. It has most of the fields that I just discussed. And this is tied within the parcel identified number used by the tax department within a relationship class with the parcel boundary. Now I created these separately to add more flexibility. Sometimes you might want to cut with a line, when you're using spatial data analyses, and this relationship class basically ensures that when you're dealing with one or searching with one, particularly within the boundary, you're going to be linked to this owner information, the land assessment value, acreage, zoning codes, and all the information that comes with dealing with the polygon feature class. But you'll be able to have that within a line feature class, and that's really what this tax pin relationship class does. Boundary type, as I discussed earlier, there's two boundary types. There's parcels, which is the default subtype. Then after that you have subdivisions, which are basically divided parcels. A couple different subdivision units will make up a parcel, and these are all sold differently with typically different owners. And this is the topology class that sort of complements this relationship class. Not only is the data connected, but we want to make sure that the topology is connected within these two as well. So this is going to make sure that the boundary is always covered by the line, that when the parcel gets moved or subdivided, make sure that that boundary is adjusted to compensate for that.